All right, let's get right into it. Have you ever really stopped to think about one of the most fundamental questions in AI? How does a machine, a piece of code, actually learn from its own screw-ups? Well, the secret, it turns out, is all about keeping score. I mean, it's a massive jump, isn't it? We see AIs doing these incredible things now, but they all start from nothing. They're totally clueless. So how do they make that leap from knowing absolutely zero to being, well, clever?
It all begins with a guess. A brand new neural network looks at some data, let's say it's a picture of a cat, and it makes a prediction. I think that's a dog. And at the very beginning, this is pretty much a random shot in the dark. It's almost guaranteed to be wrong. But the real magic isn't in that first guess. The magic is in what happens right after it gets it wrong.
To get any better, the AI needs to know how wrong it was. It's not enough to just be told, nope, that's a cat. It needs a number, a precise mathematical score that actually quantifies the mistake. And that's where the AI's internal scorekeeper comes into play.
This scorekeeper has an official name. It's called a loss function. And its entire job, its whole purpose, is to measure the gap between what the model predicted and what the real answer is. It takes the whole messy, complex mistake and just boils it down to one single, powerful number. We call that number the loss or the error. The easiest way to think about it is like a penalty score in a game. A really high score, that's bad. That means you made a huge mistake. A low score? Awesome, you're getting close. So the entire goal of the training process is driven by one super simple objective. Get that loss score as close to zero as you possibly can. But of course, not all AI problems are the same, right? Predicting a number, like the price of a stock, is a totally different game than trying to choose a category, like, is this picture a cat or a dog? And just like you wouldn't use the rules of basketball for a soccer match, you need to pick the right kind of scorekeeper for the specific job at hand. So let's look at two of the most common loss functions side by side. On one hand, for predicting a value, say a house price, you'd probably use something called mean squared error, or MSE. It literally just measures the distance between the price your model guessed and the actual selling price. Simple. But for classifying an email as spam or not spam, you'd use cross-entropy loss. And this one's a little smarter. It doesn't just care if you are wrong. It gives a much bigger penalty if you were confidently wrong. That's a way better way to learn. Okay, so the AI has its penalty score. It knows exactly how wrong it was. The next huge question is, what does it do with that number? How does it actually use that score to close the gap and get smarter for the next guess? And the answer is a process called optimization. This is the real learning part of the whole cycle. An optimization algorithm takes that loss score and uses it as a roadmap. It starts tweaking the millions of tiny little internal knobs and dials inside the network. We call them weights and biases, making these tiny adjustments to steer the next prediction in a better, more accurate direction. And the undisputed champion, the heavy hitter of optimization algorithms, the one that's used in pretty much all modern AI, is called gradient descent. It's this beautiful, elegant, and super powerful method for figuring out exactly which of those million knobs to turn and which way to turn them to make that loss score go down. So how does it work? Okay, imagine the loss score is a giant, hilly landscape, and your AI is standing on a hillside in the middle of a thick fog. It wants to get to the lowest point, to the bottom of the valley. So what does it do? First, it feels around with its foot to find the direction of the steepest path uphill. That's called the gradient. And then it just takes a small step in the exact opposite direction, downhill. And that's the whole idea right there. It's so simple when you think about it. Find the direction that makes the error worse and just do the opposite. Take a step the other way. It's a really simple principle that becomes unbelievably powerful when you do it millions of times for all those little knobs inside the network. And yeah, this isn't a one and done kind of thing. The network repeats this process, this little step downhill, over and over and over again. We're talking thousands, sometimes millions of times. And with every single iteration, every tiny adjustment, that loss score gets just a little bit smaller as the model's predictions get better and better. And check this out. This is what that actually looks like in practice. This table shows the loss score from a real training session. You can see that as the training epochs or cycles go up, the loss score just steadily drops. It goes from over 14 all the way down to under 3. We are literally watching the AI get smarter in real time. So when you put all these pieces together, you start to see that it's not just a bunch of separate events. It's a continuous self-correcting loop. This is the fundamental cycle that drives basically all of modern machine learning. And this loop has 5 key steps. Step 1, prediction. The network makes its guess. That's called forward propagation. Step 2, scoring. The loss function calculates the error score for that guess. Step 3, improvement. The optimizer works backward through the network to figure out who is most responsible for the mistake. That's a process called backpropagation. Step 4, adjustment. The network's internal weights get updated. And finally, step 5, repeat. The whole thing starts all over again thousands of times until that error is as low as it can get. So let's just recap the big takeaways here. First, loss functions are the essential scorekeepers that tell an AI how badly it messed up. Second, you have to pick the right scorekeeper for the game you're playing. Third, optimizers like gradient descent are like the coach, using that score to make the model better. And finally, all AI learning is really just this simple, powerful loop. Predict, score, adjust, and repeat. And this all leaves us with one final and really important question to think about. We've seen that these machines are incredibly good at minimizing a score, at hitting whatever target we give them with brutal efficiency. But what happens when the goal we tell them to aim for, the score we ask them to minimize, doesn't perfectly match what we actually want? Thanks for joining me.